You know when you're staring into a campfire and you see all those different colors dancing around? Well, it turns out those colors are not random at all. They're actually a kind of secret language, a chemical code that tells us exactly what's burning. So, let's learn how to read it.
Okay, so picture this. You're a firefighter and you get a call about a blaze at a mini storage unit. You get there and through all the smoke you see these flashes of a brilliant deep purple. Is that just weird or is that a critical warning sign? What is that purple flame trying to tell you?
For that firefighter, a purple flame is a massive red flag. See, a normal wood fire burns orange and yellow, but these strange colors, they scream that industrial chemicals are involved. We're talking about toxic gases that can literally seep through your skin and temperatures way, way higher than a normal fire. That color is a direct warning of some very serious, life-threatening dangers hiding in the smoke.
But how? How can a simple color reveal all of that? Well, the answer isn't really in the flame itself. It's actually in the journey of a tiny little electron inside the atoms that are burning.
It all boils down to 4 basic steps. First, the heat from the fire pumps energy into an atom. An electron inside that atom gets supercharged, absorbs that energy, and makes this big leap to a higher, unstable orbit. Scientists call this the excited state. But it can't stay there. So almost immediately, the electron falls back home to its stable, ground state. And as it falls, it has to release all that extra energy it absorbed, and it does that by shooting out a tiny particle of light. Let's just think about that jump for a second. The ground state is just the electron's normal everyday home base. The excited state is like a quick, temporary hop up to a higher step. The specific color of light that we end up seeing is determined by the size of that drop, how far the electron falls to get back home. And this is the key to the whole thing. Since every element out there has its own unique atomic structure, the size of that leap, and therefore the amount of energy it releases, is also totally unique. This means each element burns with its own specific, predictable color. It's a perfect chemical fingerprint.
Okay, so with that science in our back pocket, we can now build our elemental color code. We can finally start to read the fire's secret language.
Let's start with the most common one, the one you've definitely seen before. You know that bright, really persistent yellow you get when a pot boils over on a gas stove? Yep, that's sodium. Even a teeny tiny grain of table salt, which is just sodium chloride, is enough to produce that unmistakable yellow signature.
Then you have something like magnesium, which is on a whole other level. It produces this brilliant, almost blinding light. Its intensity is exactly why magnesium is the key ingredient in things like emergency flares and, of course, some really spectacular fireworks. It just burns incredibly hot and incredibly bright. Strontium gives us that classic deep red color. But what's really fascinating about strontium is that it's also a key player in making other colors. Remember that mysterious purple flame we talked about at the beginning? Well, you get that when you mix strontium with other elements, like copper.
And here it is. This is basically the full code book. You can see the direct link not just between the color and the element, but even the flame's temperature. Look at magnesium's white flame. It's burning at around 1,000 degrees Celsius, while calcium's red is closer to 500. For a firefighter, this isn't just some chart. This is vital intel for understanding exactly what they're up against.
Now, what's really cool is that this same science isn't just used for warnings, it's also used for celebrations. The exact same chemistry that tells a firefighter to be careful is what entertains millions of us on holidays.
So think about it. If you know that each chemical produces a very specific color, how would you go about designing a fireworks show? You'd need some kind of guide, right? A recipe book almost.
And that's exactly what it is. As our source material puts it, this chemical color chart is the pyrotechnician's recipe book. They aren't just lighting a fuse, they are performing a really precise kind of chemistry, one that's written in light all across the night sky.
So if you want a brilliant red explosion, you add salts made from strontium. If you want a vibrant green, you'll use barium. For that really beautiful but tricky to make blue, you need copper compounds. And of course, for that bright white flash, you add magnesium. Each color is a carefully chosen ingredient in the recipe. So, from a dangerous chemical fire to a breathtaking fireworks display, the message is actually the same. The light is talking to us, if we just know how to listen.
Ultimately, a flame's color is so much more than just beautiful or dangerous. It is a chemical fingerprint. It's a direct line of communication from the atomic world, revealing the very elements that build everything around us.
And that kind of leaves us with a final thought. The
The color of a flame is a code we've learned to crack. It makes you wonder, right? What other invisible signatures are hidden all around us, just waiting to be decoded?